One of the fun things about working with Hubble Space Telescope images is all those famous pictures that you know of space, of the pillars of creation or the Crab Nebula. Those are all from the Hubble Space Telescope. The project I worked on last summer with Dr. Pat Hartigan was looking at Hubble Space Telescope images of a type of stellar jet called a Herbig-Haro object. And what's really neat about these objects is they actually change and evolve on human timescales. We usually think of space as something that takes millions or billions of years to change and evolve, but there are these little microcosms of it that really do change on a human timescale, and I think that's so cool. So we had this image from 2018 and this image from 1998, and we could stack them on top of each other and kind of blink them back and forth and get a sense of how the gas was actually moving and changing and evolving as time went on. And so it was so cool to be part of a research team that was working with this quality and caliber of image. The first time I booted up that image, I was probably the 6th person in the world to ever see that object in that level of detail. You feel a little special, and sometimes you're like, I'm the only person who knows this thing. For the past year, I've been working on my senior thesis, which is all about measuring how fast stars spin so we can figure out how old they are. When a star forms, it spins really fast. As the star gets older, it starts to slow down, like we all do. Specifically, is working with data from TESS. It was launched last year, and it's been very groundbreaking. Basically, it takes an image every 2 minutes of a star, which allows me to figure out how fast these stars are spinning. If you have a really fast spinning star, it has to be young. The real breakthrough with TESS is that it is taking these brightness measurements over 90% of the sky. So we are going to be able to see basically all of the bright nearby stars in the Milky Way. That means that we can kind of create a map of the age of our nearby Milky Way galaxy. All astronomy is looking at light. We don't get to bring a star into a laboratory and do experiments on it. It's all about trying to solve problems from a distance. It's also about statistics and about coding and trying to figure out, we have such a large quantity of data, how do we streamline it and get the information we want out of it easily? And this is actually going to be a huge problem in astrophysics going forward. One of the big problems of tomorrow is how do we process all the data we're going to get and get interesting, useful answers out of it?